welcome to my talk. We're going to go over system sleep. I know you're all really excited, and I'm excited because you all decided to come in here and spend an hour listening to me as I try to convince you not to do anything, like at all. Just don't even touch your app. Okay, so I guess the first question is, why should you listen to me? Here's a copy of my bio from the website. You can read it again if you want to. But not listed on this is I work at Google, obviously. I am a developer advocate for Android. And recently I co-founded this initiative called Android Development Patterns. We have a bunch of videos online. We put out pro tips every week. And the intent here is to teach people how to do best practices, how to build better apps by knowing how to make a decision as opposed to how to implement an API. Because we have a lot of coverage on the Java docs and in our documentation and in our other videos on how things work. And we want to teach when and why things work and then how to make that decision. Am I talking too fast? Sorry. Okay, and so that's what ADP is about. The other thing that I did this year that's really cool is I created the Advanced Android App Development course with Udacity. And so we have the super cool nano degree, which is awesome, teaches you everything you need to know, or just the pieces that you might have missed. And my course is the second part of that. And once you've learned the basics of the operating system, you want to learn the fancier things, like maybe how to integrate with Google Cloud Messenger. And so that's the kind of stuff that we cover. And we're really trying to help you build not just a simple sample app, but like to walk you through how something works in its entirety. And when you have to go back and iterate on the same app that you've already finished, we're trying to get more into that developer experience when we're teaching, and so that it feels more true to what your life is, your experience is going to be. And then if it helps, I actually started learning Android last February 2014. And so I just want to say that as like a point of hopefully like comfort. You don't have to have been doing this since the beginning, and you don't have to have been doing this for a very long time to really pick it up and like run with it, because it does change every year and you can really get caught up quickly. Okay, so maybe listen to me, but if you don't, that's okay. So today, the reason we are all in this room is because battery actually matters almost more than anything else that we have. And there has been tons of press on this. You see studies all the time comparing this device to that device, which one runs better, or this carrier to that carrier. This one's clearly better for battery, doesn't burn your radio. Or, you know, buy this new thing because this tablet will last all month and this other one will only last a couple of days. And everybody really cares about getting power, but nobody wants to give up using. And so it's kind of a trade-off. And this is this big problem for users that everyone's trying to solve. So what we're going to talk about is how to solve this by not making it worse with background tasks. And so clearly, you know how this works. You've got your activity, it kicks off a background task, your activity continues. This is good for users because you're not hanging up on the frame rate. But what this is bad for is the device, because we get into this situation where every app kicks off its own background sync or job. And none of them are talking to anybody else, and nobody knows what's going on. Everybody just knows, like, I want to get this done at some point, and it doesn't really matter when, so long as it's done in time when I need it. And this is what's worse, because all of these things, if you can't coalesce them, you can't optimize for them. So we want to, at the end of our talk, move to this. We want to be able to say 3 different apps need to run a sync by this time or under these conditions, run them all together. And then later on, another app needs to run a sync, like let's run that one when we can. Like we want to be able to do this in bulk every time we can, and not every 30 minutes for somebody new. And this is what's going to save device battery the most, because we can just not wake up the CPU if it's not being used, and we can not drain the power when nobody's even in the room. Which brings us to Doze mode. Doze mode was introduced in Android Marshmallow. And the reason that it was introduced was so that we could, as a framework, take control. Other apps don't have insight into what everyone is doing, and you can only go so far to make your app okay, but if the framework doesn't help, we can't ever get to that ideal state. So, unfortunately, it doesn't really matter what API you're targeting. If your user is on a Marshmallow device, this is going to affect you. It goes back through all SDKs for any device that actually supports Marshmallow. And that's why you need to start thinking about it today, because you won't know if your users are really affected or not. So with Doze, we released this. We got a lot of kind of press, a lot of really good feedback from the developer community. So you would think we'd have a really good list of goals for why we did it, but we don't. We only have one. We just want to preserve the battery life, because by doing that, we're creating a better user experience, and that's what everyone, like when you're creating an operating system, you need to emphasize. So this is our one goal for Doze. Do whatever we need to preserve battery when we're in an idle state. When the user's not using it, we need to do everything we can so that when they pick their phone back up, we're exactly at the 17% that they had left. But I have my own goal for this talk, and here's that goal. I want you to learn to accept that your user has a life. You're spending so long building this great app that you're really invested in and you want your users to use, and that's great. Like, you should keep doing that. But you should understand what success means when we're talking about an app. At Google, we actually count success. Like, Larry Page will be super proud of you if you can pass his toothbrush test. And that means if your user is using your product 2 times a day for a couple of minutes a day, that is successful. So we're going for 5 minutes here, which means there's 23 hours and 55 minutes in every day when your user is not interacting with your app, but you're super duper successful. And when you think about it like that, it changes the way that you actually design your app, because you're not going for them using your app all day long. You're not going for constant glued to the thing, tripping over, getting run over by a car. You're going for something that's useful that they'll come back to and tell their friends about. Which means you don't need to be updating every 20 minutes. You just need to be ready when they're using you, which goes into what is Doze. So Doze is when your device is fully idle. And what does that actually mean? So what we've got here is network access is blocked. If the device is not being used, if we're in idle mode, we don't allow network access by anyone. We just turn off the radio, and that's going to save us so much battery. We also ignore wake locks. Sorry, we're in Doze mode. We don't really care that you wanted to do something or go on any further. Any alarms that you set with your alarm manager, those are going to be deferred. They're not going to run while we're in Doze, but because we'll have missed the time window, they'll all trigger as soon as we exit out of Doze mode. And finally, your syncs and jobs, they just won't run. They won't get deleted, they won't get dropped, but they will not run through Doze mode, which means when we exit Doze mode and all those conditions are met again, we'll run them as soon as we exit, unless, of course, your time to life has expired because it's no longer relevant. But we're not just deleting them because we're in idle mode. And I know that this sounds kind of frustrating and kind of scary, because as a developer, you need to know that you're the state that your app is going to be in, and it seems like this framework is standing up here telling you, we don't really care, we're deleting all of your hard work, and that's really not true, which goes back to my first point of, in 43 more minutes, I want you to walk out of here thinking, I'm not going to change my app, because I'm not being hurt or damaged, I'm just being maybe delayed. So let's talk about how we get into Doze mode. Doze mode is triggered when the device is not charging, and the screen is off, and the device has not moved in a long while. So what that looks like, with your phone, I put it down, I kind of walk away, I'm doing something more important, like talking to you guys, but when I come back over there, I better still be at 58%. I'm going to be really frustrated if I get back here at the end of this hour and I'm down to 13 because I was playing a game with my friends and it kept updating while I wasn't using it. That's just not a good developer experience. We really need users to trust that their device is in the state that they left it. So, the trade-off, though, is that as soon as I put it down, I'm not already dozing. It doesn't happen as soon as these 3 conditions are met. We're actually going to step into it. This is a timeline of what Doze looks like. We start with everything that is required to get into Doze, and then you'll see that Doze actually will give itself some maintenance windows, so we'll come back to that. But this image, which lives in our docs, is kind of trying to explain to you that we have these checkpoints that happen. We check for sensing, we check for motion, we check for battery, we check for usement, so that if you're just walking away to wash your hands or whatever, you're not going to come back and your phone's out of date. We're stepping into Doze from an inactive state so that we can be plenty confident that the user is actually done right now, they're doing something else. Okay, so those states are controlled by DeviceldleController. You can actually look into the AOSP if you want to know how this works. But all you need to really believe me is that you've got a good solid 2 hours of inactivity probably before we get into Doze mode, so you won't end up in a state where your app is just cut off in the middle of doing something. So active is where the device is actually being used. That's pretty obvious, right? And inactive is obviously where it's not being used. The screen has been turned off and there's no motion. We're not navigating, we're not playing a song, we don't have a foreground process running, we're just chilling in someone's purse, right? And then after half an hour, DeviceldleController kicks back up, kicks into idle pending mode because it's all that we were in inactive, nothing changed, no other signals were processed, and now we're just pending. So we've been inactive for a while, we may become idle, but we're waiting to be confident. And once we're confident, half an hour later, we're okay, we're idle. This is Doze, everybody. This is happening, shut it down. And then you saw those maintenance windows, that's measured by idle maintenance mode, and we also have a sensing and a locating mode, and if you want to know more about those, you can actually go look them up in the documentation. They just serve with getting to these states. So if you go back to look at our picture, you'll see that we've moved through all of these states with all of our constant checks. And we have gotten to the point where, okay, yeah, we were sensing, not sensing, locating, not locating, but we're still inactive, we've gotten to idle. And so idle maintenance, these other windows, is actually where we step out of Doze, because we understand that you don't want to be out of date when the user comes back, right? And so what we're going to do is we're going to, every so often in the idle period, we'll just give everyone a break, let them run their syncs, their jobs, update any content, and then go straight back into idle mode. And this is clean because it's our goal. We got to a maintenance window, now we get to run everything in a batch. Everything that's pending gets a chance to go, and the user still hasn't come back to their phone, so there's really no actual change to the device, but your app gets a chance to update any potential like conflicts or content that needs to go. So look, we're so close to solving our battery problem, right? Like we're there. We had our little, I can't go backward. That's unfortunate. I'm bad at slides. Okay, so we had our window. We got to hit our window. We got to run all of our batch jobs, and we hit our goal. So now that you understand how these states work, which the reason I went into this background is so that you'll understand what it means when I tell you to test your app for Doze. Because we have these super great ADV commands that will let you step through all the states so you can see what your app is doing along the way. And you wouldn't really understand what I meant by step if you didn't understand what I meant by stages. See how I did that? Okay, so your focus is on observing behavior when you're doing this, and you're seeing whether your app recovers gracefully when Doze exits. Because remember, we're aiming to not have to do any work as a result of this mode. So when you're looking at this ADV thing, dump sys is just a binary that lets you access other tools by name. And then you've got device idle. And this is a new service that was introduced so that you could manage the device idle controller. And then obviously step will let you do those steps, and H will show you all the other options you have. And then the other key to testing is you need to indicate that the device has to be unplugged. Most likely when you're testing and running your ADV cans, you've plugged in your phone to the computer and now you're charging, so you have to cancel that. But when you're stepping through and you're testing your device, all you're seeing here is whether or not you're surprised by anything, whether or not that pause has actually broken a part of your app behavior. And the idea here when we created this is that it shouldn't, because everything is on hold, everything's been paused, the user's not anywhere near their phone, and yet you're getting a chance to still update any potential content. So now the question is, how do we get out of Doze mode? And what does it really mean when we've called it quits and we're done? So the clear one here is if the device is plugged in, we don't care anymore about whether or not we're preserving battery because we're charging. Or if the device is picked up, I'm so bad at slides, then the user's clearly interested in using it again. The other thing though is that if there's an alarm, and not an alarm manager alarm, but an alarm clock, then we're going to exit Doze mode well before that, so everyone has a chance to sync before that user wakes up from their nap, right? That's a really key thing here. So we've built this entire system with one goal of preserving the battery life, and then we built it around making a great user experience so they never know that their device was idle. All they know is that they were gone for 2 days because they were hanging out with their friends and going camping, and they came back and their tablet still works. They pick it up, everything's great, and the tablet's still charged, it didn't die. And that's a phenomenal experience, and if we can nail that, we're gonna really, really make it so that everything just is great. And it also means that your app is no longer to blame in the battery list when they come back and their thing is dead, and they're why was the news running if I wasn't even here to read it? That doesn't make any sense to me. So, hopefully you don't have to do anything. You tested your app once, made sure nothing wonky happened, and then you saw, okay, great, I'm good, I'm done. But if you actually do have a use case and you want to adapt your app for Doze, here's what you need to do. First step, consider the flow of your app. Kind of talked about this, but will Doze affect it? If you think about how your background syncs run and your jobs run, how important are they to the core function of your app when it's on a time schedule, or what expectations your app has for something being done already? Likely this shouldn't affect it because, like I said, we stepped into this carefully. We accounted for things like alarm clocks into user usage. But if it does, you'll want to take a look at that. So a common solution here, and this is actually just a general best practice, is to use downstream messaging. If your server is expecting your device to check in on it and it misses that connection, you might think that something's wrong. But if you've built your app so that your server sends interesting information to the device instead of having to have a call in, then you're going to have just a much better user experience in general. And then, if you're using Google Cloud Messaging, you can take this further and have a high priority tag. It's really easy to add. You just add priority high to your data as you build your object for your message. But a high priority tag is going to be given exceptions from Doze mode. It's going to be given a chance to wake up a receiver, process that message, potentially react to it. Maybe you need to generate a notification off of that. And this gives you a temporary reprieve from Doze. So most likely you'll go right back into idle mode, but if that notification draws the user's attention, then you're going to be able to exit Doze mode entirely because the device will have been picked up. So you really get a chance to react to anything that's critical, like real-time messaging and all kinds of apps like that, or maybe a severe weather alert. I mean, it could be any kind of thing that might drive them. But it's not everything, and I want to stress this because high priority should be treated with care. And what high priority really means, and it's very simple to remember this, is if I have to get up, walk across the room, pick up my phone when I was doing something more important, like giving a talk, and look at it, it better have been worth it. And if it's not worth it because you just wanted to tell me that I got a poke from a friend, that's not the same thing. So not everything's high priority, which is why you add the tag to what counts, and then the rest of the time, everything will be processed normally as soon as the device is idle again. So we're really trying to build, overall, just a great user experience with this entire program. Okay, the other thing is some things legitimately are time critical. You really do need it to trigger at exactly the right moment. Maybe you have a reminder app, or maybe you have calendar invites going. And these, we actually built an alternative for you. We created new alarm manager calls. So instead of calling set or set exact, you'll add and allow while idle. The methods are actually exactly the same. They take the same parameters in the same order. They're identical to their counterparts in all of the calling. The only difference is that they're honored whether or not you're in Doze. So it's a really easy swap for any developer. But the one restriction that we added is that it can only be triggered once every 15 minutes, which is actually incredibly reasonable if you think about a device in idle mode. If you didn't get the user's attention the first time, they probably don't care 2 minutes later. Right? 15 minutes is actually a very reasonable window, and it allows for things like a calendar reminder without necessarily, triggering every 60 seconds, waking up and checking to see if new content came in. Okay. And the final thing, which I already mentioned, is you really need to test your app. Make sure that you don't get surprised by anything, because if you're surprised, your user's going to be surprised, and then that's just going to result in uninstalls or not using your app or lower engagement because they don't know how to use it. So classic advice here, all around, not just for Doze. Just test the app and make sure it works. The other thing is I need to mention that there is a whitelist for Doze as an exception, but it's only for a few very special use cases and is subject to the Play Store developer policy. So most of your apps probably won't need this. But if you do have questions, you can feel free to ask me later or check the documentation on how that whitelist works. Okay, so that's Doze mode. It has a counterpart, and that's called App Standby. And this was also introduced in Marshmallow, also affects all M devices, whether or not you're targeting it. But the difference here is that App Standby was created for apps while the device is still running, while Doze touched on the entire device. So while Doze might result in maybe everything being out of sync by about 4 hours, App Standby could mean that your app hasn't gotten any attention in a couple of days. And that's why you have to think about this differently. But again, we have one goal, preserving battery life. And so that's the main thing to keep in mind as you go through this. So it's the exact same problem before. We need to achieve this as much as we can, and apps that aren't being used are a drain on the battery when they're syncing. And so we want to batch all of those, and our maintenance windows will let us do that. So kind of why have both? And here's the main use case. So App Standby and Doze are different in the main sense of what they affect, an app at a time or the entire device. They both restrict network access so that nobody can access the radio while they're in this mode. They both halt all jobs and syncs because those are the things we want to batch. But alarms and wake locks are both going to be honored while we are in App Standby. And this is what's going to make all of the difference. Because if your app hasn't been used in a while, but is put on the standby list, and then your alarm is triggered because you have maybe a daily reminder, or you have something that's important and you need to present that to the user and get their attention back to your app, you're out of App Standby. As soon as you present a notification, that's you're good to go. So you're not forced by the system, you're just kind of halted while the system notices you aren't being used. And then as soon as you are being used, you're immediately released. And you have a little bit of control over how that gets triggered. Okay, so when your app is actually put on standby, it's because the user isn't using you. They haven't opened your app, they haven't interacted with your app, they haven't really kind of touched it at all in quite a long while. And you don't have a foreground service or activity or another app using a foreground service that you wrote. You're not playing any music, you're not streaming anything, you're just kind of chilling. And then finally, you don't have any pending notifications. And so this is why honoring wake locks and alarms is so important, because you do have a chance to get yourself out of standby, but for the most part, you are only put on standby because you were actually like just chilling, like nobody was using you. So it's not that you're not a successful app, like you're still passing the toothbrush test, it's just the other 23 hours of the day. Okay, so app standby ends when the user launches your app, obviously, or the device is plugged in, when all apps are released from standby mode because we don't worry about power anymore, or when any work that you're doing based on your wake lock or your alarm manager is creating a notification. Super, super easy. But I guess you're kind of wondering, like, why really bother with that if it's so much controlled by the developer? The main thing about app standby is when you're in app standby mode, we offer those periodic maintenance windows similar to Doze, and you have a guaranteed maintenance window of at least once every 24 hours. So think about an app that you don't use often, like maybe a movie player, right? Like you want it to be ready when you're ready to buy or rent or stream a movie, but you're not going to open it every day or multiple times a day. However, all of that content that it offers to you, that's licensed content, and if you don't update that license regularly, you're legally obligated to delete the content, right? Because it's an ownership question. And so in order to let the content be refreshed and change the list of like movies, and in order to make sure they're all valid from the things you already paid for as a user, you need a periodic maintenance window, but your app doesn't need to be syncing like all the time or like 3 times a day, because you might not use it for 2 months at a time, but it doesn't mean it's not one of your go-to apps. Similar to things like, buying movie tickets, like all of these things are very useful applications, they're just not used all day long. And that's why we created this, because we want to empower those applications, but also trying to like let them know that they're not, don't drain the battery, like we'll put you together with a bunch of others and everyone will have a much better time. But the trick here is you probably still don't have to do anything. If you're reacting to a broadcast or a message the way you normally would, then you're going to produce a notification and get yourself out of standby. And if you're, building an app that like runs a sync every so often, it'll still run every day. Like, still hitting my goal from the beginning. We're not changing anything. But when you do need to adapt for app standby, it's exactly the same as before. A GCM high priority message will break through and give you network access so that you can run a sync in response to some sort of message. And so really all you have to do is a couple of tweaks here and then you're really good to go. Like if anything, like I said, maybe it doesn't affect your app. But that CPU time, that network access, you can get it when in response to something important. But keep in mind what counts as high priority. If you don't want to get up from writing some code and go and check your phone, probably don't want your user to have to like interrupt their day when they're not actually on the device. Okay, so this results in a final list of like, why did you tell me all this? Like, what do I actually have to do? Do I have to like test my app or not? And I mean, you do, that's true. Both App Standby and Doze, they're going to be affecting your app. Like no matter what you do, you're kind of stuck with it. It's part of Marshmallow devices, it's coming. So you should be considering this already. But we need to keep radio and CPU off as long as possible so the device can stay on. And you have to have all apps participating in this to achieve this goal. Just a few inactive or just a few active ones that are exceptions that can actually undermine the entire purpose of an idle mode, right? So the key here is to understand what has changed. You can't depend solely on wake locks and alarms because their behavior isn't exactly right. And if you have something that is critical or sensitive, you're kind of, you're catching yourself here. However, you can count on the fact that all of these things are going to trigger. They just might be deferred. So really, nothing changes in the overall picture. It just, like I said, you may be in a situation where Doze has put your device a couple hours out of date. And you won't notice that until the user picks it up and then it runs a sync. So maybe there's a long loading window. And if that's bad for your application, you need to be considering that when you're scheduling your jobs and your syncs. Which leads to my to-do list, super duper hard. Like I said, considering the flow of your app, you need to make sure that everything behaves the way that it should behave for the best user experience with the potential of being a couple hours late. You need to update any time-critical alarms to include and allow while idle. And you need to consider any urgent or critical downstream messages as high priority with GCM. And finally, you really have to actually test your app. You need to see how it reacts to a sync or a job when it's delayed because of Doze. And if you're not happy, you have to return to step 1 and do the whole thing again. But if you actually are happy, then you're done. Like that's all the integration that's required for Doze. Which leads me up here to stand up here and stress again that like, this sounds like a really frustrating thing because developers don't have any power here, but we actually designed it so thoughtfully that you shouldn't have to do hardly anything at all. There are a few special cases that we really did think about. Like you really do need to know what's going on here, what's going on there, and then maybe you're frustrated because the 15-minute window doesn't work for you, but you're also considering the fact of if you can't get the user's attention with an alarm every 15 minutes, they might really be doing something important, which goes back to my toothbrush test. Like, users do have lives, and it's hard to remember that because you get into this point where you've spent your whole life kind of like every day building this thing that matters so much to you. But if you think about it from a user perspective, how do you use it? And how will a user use it? And what does it do to the battery? We're all trying to make a better system here, make a better ecosystem. And that's why we have Doze mode. So test it thoroughly, test it using ADB, it's pretty great. And we have a special one also for app standby with inactive, and you can set inactive or not to see, put yourself on the standby list and see how your app interacts there. All of this is documented thoroughly online. We have a couple of videos to help you out, and of course you can always message me with specific questions or any feedback or anything you want to know. If you want to learn more about how actually background tasks work in general, I'm going to go over that at 4 o'clock, how to use job service, how to build an intent service or use a broadcast receiver, how to actually make a background task, because that's a completely different problem. But as for saving your tasks from Doze mode, you really hopefully shouldn't have to worry. It shouldn't be any work for you, and I hope that that's what you discover with your app. Okay, cool. You're all done really early, so if you want to ask me questions, I'll just be like right here. You've got 15 minutes of your day back to go get lunch.